This is part 6 of a series of videos on graphing exponential functions, and in this one we're focusing on graphing exponential functions in HK form. Right? So here's an example right here, numerical example. Here's the generalized form. Now remember, the h and k, the h moves it left and right and the k moves it up and down. The h changes signs and the k doesn't. So in this case, let's look at the steps. The very first step is you're going to identify what's called the parent function. And what I mean by the parent function here is the parent function is the function before you've shifted at h and k. And so in this case, the parent function here would simply be y is equal to 2 times 3 to the x. And it's good to go ahead at this point to go ahead and identify what the h and k, what the type of function it is here. So if you think about what type of function it is here, you know that b is greater than 1, so it's exponential growth, but a is positive, so it does not flip. So it's an exponential growth function, but it doesn't flip. And you need to memorize these 4 graphs. And if you think about which of these 4 graphs it's going to generally look like, it's going to look like this one right here. The asymptote is going to be y equals 0, and the y-intercept 0, a, before you shift it. So the second thing you want to do is you want to identify the new asymptote. So here, let's go back to our 4 graphs. Before you h and k it, each one of these has what's called an asymptote, and we don't focus that much about what the asymptote is because it's always the same, right? You need to memorize what it is, but it turns out that in this case right here, then you have an asymptote y equals 0, same here, and same here. So in all of these, you have an asymptote with y equals 0. So let's think about asymptotes for just a second. If you have an exponential growth, or for that matter, an exponential decay function, then what you have is let's look at exponential growth. It looks something like this. And if you notice, what happens is the graph gets closer and closer to this x-axis, which formula is y is equal to 0, but it never actually reaches the x-axis. And we call that an asymptote, and you can think about that as an imaginary line or a dotted line or a property of the graph. You can think of it a lot of different ways, but it's connected intimately with this graph. So the key is that when you take this graph and you shift it left and right and you shift it up and down, the asymptote also changes. Here's the trick though. If you take a horizontal line and you shift it left and right, it doesn't change. But if you take a horizontal line and you shift it up and down, it does change. So this is actually a pretty easy problem to find the new asymptote. All the asymptotes start at y equals 0. And if you shift them left and right, they don't change. They're still y equals 0. But if you shift it up and down, it is. So what we might call the new asymptote, that is the asymptote after you shift it, is going to be simply y is equal to k. And that's a formula that always works. So if we go back to our steps here, the very first step was to identify the parent function, and the second step is to identify the new asymptote, and the new asymptote will be y is equal to 5, because k is 5. The next step is you're going to want to find a single point. And there's a lot of ways to do that, but there's one particular way that I like to do it, both because it's a very important point and also because it's a very easy point to find. So from the parent function, you know that the y-intercept is going to be 0a, or in this case, it's going to be 0, 2. But let's see what we're going to do with this parent function. We're going to shift it left and right and up and down. We're going to shift it, that's h, but it's 4, so that means we're going to move it left and right. We should change signs so that it's -4, so we're going to take the 0, 2, and we're going to move it back 4. But we're also going to move it up 5. And if you take 0, 2, and you move it left 4 and up 5, you get the new point, which is minus 4, 7. So now what do we know? We know what the parent function is and the general shape of the parent function. We know the new asymptote, and we found 1 point. So the next step is simply make a table. So we have a single point, so let's make a table, and let's put that point in the middle. If you put that point in the middle, and that point is going to be minus 4, 7, then let's choose one value that's more positive than minus 4 and one value that's more negative. So let's choose as a more positive a minus 1, and as a more negative, let's choose negative 6. And we can choose any values of x we want to, and the way that we find y is we plug these x's in. So you get y is equal to 2 times 3 to the minus 6 plus 4 plus 5. You have to remember your PEMDAS rule, so that's 2 times 3 raised to the minus 2 plus 5. You want to do exponents next. So 3 to the negative 2 is 1 over 3 squared, or 1/9. And 2 times 1/9 is 2/9 plus 5. Now, usually in math we like to use fractions rather than decimals, but the real exception to that is when you're going to do graphing. So let's make that into a decimal. That's 2 divided by 9 is 0.22 something. So y is equal to approximately 5.2. Now let's plug in minus 1. You have y is equal to 2 times 3 to the minus 1 plus 4 plus 5, which is equal to 2 times 3 to the minus 1 plus 4, that's 3 plus 5. 3 to the third is 3 times 3 times 3, that's 27. So you have 2 times 27 plus 5, which is 54 plus 5, or 59. And then again, you put the point the single point in the middle of the graph, and you choose one positive, one negative. Now the last thing you do is just sketch a graph. So let's just make a graph and write all these. Now, you almost always when you graph use graph paper, but I make an exception with exponential growth because sometimes you're going to get values which are really large, and you kind of want to just get a sense of generally what the graph looks like. So the first thing I'm going to do is I'm going to graph the asymptote. Remember, the asymptote was y equals 5, because the formula for an asymptote is just y equals k. So 1, 2, 3, 4, 5. The asymptote is a horizontal line. Asymptote y is equal to 5. Then I'm going to simply graph my 3 points. Minus 4, 7. 1, 2, 3, 4. Say is right there. And then you have minus 6, 4, 5, 6, and 5.2, right? Minus 4 and 7, minus 6 and 5.2. One, 2, 3, 4, 5.2 is going to be about there. And then you have minus 1 is 59, so that's going to be really way up there. So you don't even have to graph that, we just have to know where it's headed. This is coming down. Remember, an asymptote you get closer and closer to, but you never graph it. You might want to label a couple of points. And that's how you graph exponential functions when they're done in H and K.